The first one has to do with converting between rational power form and radical form. Okay, whenever you're looking to move between the two of these, if the radical form is nth root of a to the m, it's equivalent to a rational power of taking the base that stays the same, so a, and part of that base is a to its power. So a to the m stays the same. Nothing changes there. The only thing that changes is the index is the denominator of the rational power. Okay, so when you rewrite this radical into rational power form, you get the base to the power of m divided by n. That index becomes the denominator of your rational power. Again, rational meaning fraction, the power that's written as a fraction. And be aware of that relationship. Okay, now, you can also move it in the other direction. You can move it from a rational power into radical form using the same idea. So if you took, let's say, the base b to the power of x over y, okay, this is equivalent to taking the root of your base b, your power stays the same, so x, and the index of your root, the nth root that you choose, is whatever's in the denominator of your rational power. So it's the y root of b to the x. Okay, so again, you do need to know how to transfer or translate back and forth between these roots. All right, so if you're looking to convert forms here, I'm going to give you here's two radical forms and then two rational power forms. Again, just take a moment or two, see if you can figure out or identify what the opposite form would be. So convert radicals into rational powers, convert rational powers into radicals. Right, with the first one, square root of 5. Okay, you take your base of 5 to the power of the unwritten power in our base is a 1, divided by our index, it's an unwritten 2. So 5 to the power of 1/2 is the rational power form of square root of 5. And so for the second one, we take our base of 4 to the power of, again, it's an unwritten 1 if you're looking at it in that form, all divided by the index, which was 3, so 4 to the power of 1/3 is how you would write this. And now, another thing that you could do, and we'll talk about this in just a moment, and that is, if you recognize that 4 is a perfect power, right? 4 can be thought of as what exponential form? A base of 2 to the power of 2. So we could have also thought of this as 2 to the power of 2 divided by our index of 3. So these are equivalent here. And in the problems that you're going to face, you just need to write your base. You don't need to recognize whether it can be transformed, and just leave it as it is. Okay, let's convert from the rational power form into a radical. Here we're going to take our root. The base is going to stay the same, so 3 inside. Our power stays the same, so squared. Our index goes outside the radical, so the cube root of 3 squared. And if we simplify that more, we get the cube root of 9. You can just expand it out. And then 7 to the power of 1/5. We take our radical, the base of 7 to the power of 1, so we can just leave it 7. The index of 5 is written along our radical.